Hello everyone, welcome to Intellipaat's live webinar on Understanding Spark, the heart of big data. Today's webinar is conducted by Mr. Anurag Singh, who is a self-motivated, goal-oriented senior artificial intelligence engineer who has specialized in big data, data science, machine learning, and AI. So guys, without any further delay, let's welcome Mr. Anurag into the session. Over to you, sir.
Hi everybody. Welcome to this webinar on the big data and the heart of big data, which is Spark. So let's start today's session. So okay, so the agenda for today's discussion would be to understand what is big data, what are the processing capabilities which are available in the market for big data. We will cover a brief history about big data and then why all of a sudden we have a hullabaloo about big data everywhere. And with that, let me start. So, what do we understand by data? Data, everybody nowadays, everybody says that data is the new oil. We need to harness the data. And most of you would be hearing all these comments across your organization or from your seniors or from your teammates. So, first, let's dive into what is data. Data is nothing but an entity which will be able to provide information about something, correct? So data about you can be your name, your age, your date of birth, your qualification, and things like that. So but any information which provides value to an entity is a data. So all this time we were into the relational world until 2010. No penetration of internet. People were not that used to smartphones. Internet penetration was very less. Social media has not has been engraved in our lives. So everything was running smooth and fine. Okay, so then 2010 onwards, the penetration of the internet started. People started getting smartphones. There was an All of a sudden there was something called cloud which came into picture. People started moving from on-premise world to the cloud world. So cloud is nothing. In short, it is you can say a big rental provider. And I would keep this webinar very generic. I would not get much into the technicalities. I would rather like to take it as a storytelling way, right? So that I don't understand the dynamics of the crowd who have joined. So let's keep it generic, open, so that you get an insight into the world, right? And then probably during your certifications, during your classes, you might come to know more about it. Okay. So having said that, is something which provides value to an entity. Now, 2010 onwards came the world of big data. So, why all of a sudden data became big data? Because with the advent of cloud, what happened was storage became very cheap. Okay, and cloud also started offering one thing. It separated your storage and the compute layer. So now I'm giving you a webinar now. I'm giving a webinar over here. What happens is I have switched on my laptop. So once I have switched on my laptop, what happens? There is a processing that's going on, right? You go to your task manager, you will see that some RAM is being consumed and some ROM is being consumed. So probably your memory and your processing. So at the end, everything in the computer world boils down to binary zeros and one and processing and storage. Okay, so until early 2010s and all, we were in the data warehouse world. So everybody understands what is, say, a relational database or a table based structure. So a table based structure is nothing but, say, a student joins a school. Okay, so once he joins a school, he is provided a roll number, he has a name, he has a class teacher, he has a class, and he has subjects assigned to us. There can be n number of columns, but we'll restrict it to few columns over here. So every entity over here, so entity, consider entity as an object. So every student in a school will have a roll number, name, uh, class, a class teacher, and set of subjects, right? So we will be able to capture all the details of the student in a tabular format, which is with rows and columns. Okay, now come to the social media scenario, right? So you let's take an example wherein you are providing review for a movie. Okay, so nowadays everybody wants to say provide some reviews, or let's not go to the movie scenario. Let's take an example wherein you are doing a course from an institute, and you want to, and after completing the course, there were 50 students in the course. Everybody wants to provide a feedback for the course. Okay, so in a class of 50 people, there would be few people who would be very camera shy. They would not want to go, they would not go on camera and what do I say? They would not want to go on a camera and give a video interview or say a video review for the course. So these guys, usually they would prefer to give the reviews in a textual format on a Twitter or say on a LinkedIn and things like that. Okay, so he can go on LinkedIn, he can post a comment about a particular institute's course. Okay, then he goes to Twitter and he gives recommendation for a course, that okay, I have done this particular course from an institute and this was a very good course, it has helped me progress in my career, right? So in LinkedIn and on Twitter, what he does, he can provide textual informations, right? So it is an open text, he can write anything over there. It's just that in Twitter the text would be limited. In LinkedIn he can go ahead and he can write a kind of a small essay, right? So same text format, but on LinkedIn, say he writes a review for 3000 lines, and on Twitter he writes the review of 2 lines. Okay, or say 300 characters. He writes 300 characters on LinkedIn, Twitter he writes 3000 characters on LinkedIn. Okay, and on LinkedIn, apart from the textual context, he has also put some photos of the class and all, right? This is some information he has provided. Now some people in the class, they are very outgoing, they want to come on camera and provide a interview for a interview video, like okay, this is what I feel about the course. So they go on Instagram, they do some kind of a reel, they go on YouTube, they provide a complete 30 to 45 minutes of interview saying that how this course has helped him progress in his career, right? So we talked about text data. What was it? It was the review for a particular course of an institute. Now we are talking about video data, which is also a review for a particular course on the of an institute. Both are for the same course. LinkedIn and Twitter, Instagram and YouTube. See, textual data is also different from each other, because on LinkedIn he has written 3000 lines with one small picture, and on Twitter he has written 300 lines. Or in the video interview, somebody has, the same guy has put an interview of 40 minutes in YouTube in an MP3 format, just an example, or say an MP4 format. And on Instagram he has put a reel for 2 minutes, or say probably 1 minute, and it is a graph GIF or things of that sort, right? Now somebody goes and he does not want to come on camera, he does not want to write as well, but yes, he is a very good speaker. What he does, he goes on some of the podcast channels, or say he goes on Google Podcast or Spotify, and he provides the review about the course. Okay, so he goes on the podcast channel, and in one of the channels he gives the review for 10 minutes, in another channel he gives reviews for 30 minutes. So do you see But compare the same thing to the previous world of relational database of rows and column, wherein a student joins a school and every student has a roll number. There can be no student in a school without a roll number. There can be nobody in a school without a class or a class teacher or a subject, right? That kind of entity will not exist. But in a class of 50 people who are doing a particular course from Intellipaat or from another institute, and these guys have given reviews. But you see, somebody is giving reviews in writing, somebody in video, somebody in audio. Within the video, within the audio, within the text format as well, you see that the formats are different, right? Say you have a YouTube channel, you have .mp4. On Instagram, you might have say .mp3. In Twitter, it is say .json. In LinkedIn, it is .text. Things like that, right? So same information, different varieties are present, right? And different contents are present for the same data or for the same entity. And what is the entity? Review for a course, correct? So you see how the format of data has changed, how the structure has changed over a period of time. So if somebody would tell you that can you prepare a tabular structure out of this review, it won't be possible to capture your data in a tabular format for a review of a course wherein somebody has done. And there would be some people who would not, or say 50% of the people would be, I don't want to talk about the course, I am not giving any reviews, whether it is on LinkedIn, Twitter, Facebook, Instagram, wherever. I simply don't want to give a review. There would be few of that kind of people as well. But can you imagine this scenario when a student gets enrolled in a school and he says that I don't want to have a roll number, I don't want to have a class, but still I want to be a student. That's not a possibility, right? So this is where the information for a school student you can capture as a row and column, but the same information for say a review of a particular course with a lot of options available to the people, you will not be able to capture in a proper row and a column format, right? Because there would be some people who would not be interested, there would be some people who would want to go on the different channels, which we discussed a few minutes back, right? So for collecting such so how you see the data has changed over a period of time. So the previous data in relational world could be considered a data, but data in the social media world, data in the year after 2010 12 could be considered more of a big data. So what how do you differentiate, or how do you understand that data is big for me? All of a sudden it was small, but suddenly you see data has become very big. So there would be some property or some characteristics which would be defining that my data was small all this time, but all of a sudden this particular data is a big data, correct? So but there's a industry wide accepted I would say an industry wide accepted uh, criteria which puts the data into the category of the big data. So basically people, three important V's, or say velocity of the data, variety of the data, veracity of the data, and volume of the data. Okay, so the very four common V's, four V's of big data: volume, velocity, variety, and veracity. Okay, usually three is more important: volume, velocity, and variety. Veracity is still I would say a so-so situation, but three very important. Volume, see, when data can be stored as a relational table in an on-premise system or in GBs or say gigabytes, it is still data. But the moment the volume of the data explodes, so you see, the once try downloading the movies from YouTube or from any channel, and you would see those movies will go out in GBs and GBs of data, correct? So you see, all of a sudden volume of the data increases, and that data can be categorized as a kind of a big data. So we are not no longer dealing in, say, MBs and GBs of data. We are dealing in petabytes of data, zettabytes of data. So, like, I would say 1,000 GBs, 100,000 GBs, and things like that, right? So, no longer in GBs, data comes in huge volumes, which is like terabytes and petabytes of data. So, volume is one characteristic. Then comes the velocity of the data. So, what do we mean by velocity of the data? Different speeds with which the data is coming. So imagine the relational world of a student. Try to relate the school scenario to a store scenario as well. Say a sales store or something wherein you are doing some sales. It would be like, after the sales are happening, you are putting an entry in the database. After the students are admitted to a school, you are putting the entry in the database, correct? So that is what, you have the same velocity, correct? There is no difference in velocity. The moment one students get admitted, you have an entry in the database. The moment another student gets admitted, entry in the database. But in terms of the social media things, 50 people you said to put reviews on, put reviews for a course, 5 people are putting YouTube videos simultaneously, right? There is no synchronization, there is no sequential thing. Everybody is putting together. There is one smart guy who is typing on, say, who is typing a review on LinkedIn on his phone, and the other side he's preparing a video out of it on YouTube. So some people who are like able to do multiple things at a time, right? So you see, the same kind of data comes in different volumes as well. There is no kind of a batch process or a fixed interval. It can come at any volumes. It can come at any velocity. So we covered volume, velocity, variety. So variety, I need not go into the details. You have a video review, you have an audio review, you have a text review. So see, same data, different varieties, correct? And then we have veracity. Veracity is nothing but how reliable the data can be in future. So that's one of the components. Okay. So this was about the big data. This was about the big data world. Okay. The 4 V's of big data and things like that. Now, when data was an ordinary data, everything was fine. You could run it on your laptop or in your virtual machines or in your computers. Okay. But as we say, no, with uh, some if something new has come, then you have to tackle the problem in a very new way. So as and when data became started becoming big, what happened was, it was very difficult to tame the data, or it was very difficult to process the data. Because see, my 4 GB machine, 10 GB machine, 16 GB machine, or a normal laptop is just a machine with, say, 10, 20 GB, maximum 16, 30 GB of RAM, which is limited in capacity, correct? It will not be able, or if at all you want to use it for your this one, if at all you want to use it for processing your big data, it will take a very very long time. Okay, so we will take one small example. So what happens is, somebody came to my house, and or say, there's a function going in my house, and what he says that, Anurag, I have this he gives me a basket of flowers, and he says that, Anurag, I'm very busy. Can you do one thing? If you are free, can you just separate these flowers into separate these. Can you please make a count of these flowers and tell to me, because I have to sign the invoice saying that okay, I have got a good delivery. So probably the say the contract was for getting 50,000 flowers. Okay, so somebody has given a basket to my neighbor, but my neighbor is busy, so he comes to me and he says that Anurag, see, the contract was for 50,000 flowers. Can you do one thing? Can you please check it so that I'm very busy. So I will have, what will I do in such a situation? I would sit with the basket. I will start counting one by one. Okay, what happens? I start in the morning and counting 50,000 flowers. It will be evening and probably I'll still be counting. Correct? Because I'm limited by speed. I'm just one person. Maximum, say, one or two. I'm picking two flowers at a time and counting and keeping it in a separate box, making a count of it. This is the traditional approach of a CPU based system, okay, which is a sequential programming. Everything will be processed sequentially. But say with UC Berkeley, most of you might be aware, Apache Foundation and things like that. So these researchers in UC Berkeley, they came out with a solution to this problem of big data. They told that, see, what we have been doing traditionally now, we have been using one machine for processing the data. So there is only one person, Anurag, who is, say, counting the flowers with his hand one by one, and he will take time from morning to evening. But yes, he will not fail. He will give the count, but he will take 10 hours to count this whole 50,000 flowers. Now I tried acting smart, and what I have is, I have, say, 10 or 100, say, I have 10 kids in my apartment who usually play in the park. Okay, so I'm friends with them. What I do, I go to, and it's an evening time, so I go down. I will say, hey guys, let's do one thing. I have a game for you to play. So I would want you to do the counting of the flowers for me, and whoever counts, everybody will get a piece of chocolate from me after he does his task. So those guys are also very happy. I'll say that, okay, but this will increase your number counting abilities and all small kids. Okay, so they will be like, okay, yeah, we'll play the game. So I'll call them to my house. I'll make them sit, and then what happens is, without doing the exact count of the flowers, what I will do, I'll put my hand in the basket. I'll pull a bunch of the flowers and I'll give to one guy to count. I'll put my hand in the box again, put pull a bunch of flowers, give to second child, and do the same for all the 10 children. Okay, so here I'm not counting or distributing the flowers equally, but I know that, okay, I'm just picking it with my hand. However, how much ever flower is coming, I'm giving it to different people, or the different kids. Now what happens is, in this scenario, what happens, one guy will, probably 10 people are there, so everybody is getting, say, 10, 20, or 50, some say 1,000. Say, just consider that 1,000 flowers. Somebody is getting 1,000, somebody is getting 800, somebody is getting 1,800, somebody is getting 1,500, and things like that. Okay, everybody is counting. So what do you see the smart move over here? Don't you see that the same task which I was doing alone took me 8 hours to count 50,000 flowers? But I acted smartly. What I did, I distributed the tasks among individual people, and everybody has got, say, 1,000 or 500 or 1,800, depending on how much ever I have picked in one of my hands and given to him. So these guys are counting within, say, 1 hour. Everybody will be able to count 1,000 flowers. So one of the kids, he counted and he comes to me and he says, Anurag, I have 1,200 flowers. The other guy comes and he says, I have 800 flowers. The other guy comes and says, I have 1,800 uh, flowers. The other guy comes and say, I have 1,200 flowers. So you see, the same task of counting 50,000 flowers, which was taking me individually 8 hours, the same counting probably I would have done in an hour's time or so, because one person is just counting say 800 to 1800 flowers which he can count within 1 hour, right? So and the work is happening simultaneously. So after the end of 1 hour or 1.5 hours, everybody is coming back and he's saying, Anurag, I have 1200, I have 800, I have 1800, I have 1200, and things like that. So what I do, I being the master for them, I'm just making a count that okay, person A 1200, person B 800, person C 1800, person D 200, right? And what happens is, for me, the task is very simple. I just calculate how much everybody has given, and I say to them, my neighbor, that yes, boss, I see that there are 50,000 50,000 flowers. You can take your, you can sign your invoice as okay and send it to them, or pay the money to the guys, flower guys, right? So see, this is a smart move which I did, right? I distributed my I distributed my work. That is where, with the advent of big data, came the concept of Hadoop distributed file system. Okay, so it is nothing but it is a distributed network which processes your big data in a distributed way. So say that you are working on 1000 GBs of data. What happens? You distribute it to 1000 people, and everybody is just working on 1 GB of data, which is very easy to work with, right? And then at the end of processing, you being the master, calculate the sum or whatever is required and provide the result. One very important thing in this environment is that you need to have a master for it, right? Because if you do not have a master, what happens to the cattle on the road? You see a person who is there with the stick, somebody is there in the front and somebody is there in the back, right? Who keep them in the track. Because see, the more distribution you do, the more you are losing control of things, right? So you need to have a strict control over the data. The same thing applies to classes as well. When we were children, we were in school classes. What teacher used to do, they used to appoint one or two monitors depending on how naughty the class is. If the class is very naughty, they will have two monitors, so that when the teacher is absent, these guys will keep control of the class, so that nobody shouts, nobody beats each other and things like that, right? So that is what, for distributed system, it is very important to have a master. And that is where these distributed concept, when this distribution concept came in Hadoop and all, they had a master as well as worker nodes. So one laptop will become the master and another 10 laptops will become the workers for the master, right? And everybody will report to the master. Because imagine, in a distributed world, if you do not have a master, how do you know what you have to do? How do you know what end result you have to provide, right? So your project manager comes to you and he says that I want this use case to be delivered in 15 days, correct? So he is your master who guides you or who tells what is required. Same is the concept for distributed networks and all, right? So everything was working fine. The concept of Hadoop MapReduce came into picture, which was a distributed processing engine for big data. Okay, now see, everybody uses, a lot of organizations still use Hadoop. Okay, why I'm saying still is because I'll come to that point, right? That everybody uses Hadoop. It was a very big, very good big data engine. People were very happy. They were able to use Hadoop for all their distribution. So now, and I go to the evolution of Hadoop environment. Okay, so this is what I would say. It's sometimes very good to be greedy. Okay, because greed, as we say, necessity or greed is the mother of inventions, right? So the more greedy we become, the many times, I would not say greed. Don't take greedy in another sense of say, wherein people start committing some activities which are not required, but greed in the sense a smarter greed, wherein I want to be smarter and I want to achieve my tasks very faster, right? That I'm talking about that kind of smartness. Let me not call it greed, rather let me call it smartness over here. So it's always good to work with smart people, everybody, because smart people will always keep on seeing that how your things can be optimized and how you can get uh, get and most out of anything, right? So all this time Hadoop was working perfect, everybody was very happy. But the same people in UC Berkeley were still, see, intelligent people, PhD holders and all computer geniuses. They still thought there is still a possibility wherein Hadoop environment can also be, we can go somewhere faster than the Hadoop environment as well. So, okay, we are happy, we are able to get the results, but is there anything else which can be done within this big data processing environment so that my processing becomes more faster? So same flowers I'm counting, one person is counting 50,000 flowers, he takes 8 hours to count. But the moment he distributes it to everybody, he distributes it to everybody, then everybody is within 1 hour time he's able to count 50,000 flowers, correct? Very happy. But people were still thinking that is there any possibility wherein I can reduce the timeline even further, rather than say getting the task done in 1 hour, can I get it done in 30 minutes? Is there a possibility? Let's work towards that. Okay, so these guys in UC Berkeley, Mark Zaharia and Ali Godse, these guys, computer geniuses of their age, these guys started working on something called Spark, okay, which was an evolution of the Hadoop environment. So see, Hadoop, now the next version, I would say, or an evolved version is something which is called Spark. So see, the name itself suggests Spark. It means that fraction of a second, right? We'll say the, but the accident just happened in a spark of a section, spark of a second, like without realizing itself, the accident happened. It happened so quickly, right? So they came with an evolution on the Hadoop environment that was way back in 2016, wherein these guys came with something in the name of Spark. Okay, so which was a next generation or an evolution over Hadoop. Now every Hadoop, the concept still remains the same. You still distribute the environment, distribute your processing, you still get your tasks done by multiple people. But what so basically any, when you are writing something, so I'm showing you a PPT, what is happening? There is a processing, as I said in the beginning, there is a processing that's happening, right? Your CPU is consumed and your hard disk is also somewhere on the hard disk as well, you are storing the data, right? So when you are storing something on the hard disk, what happens? It becomes a permanent storage for you, right? There is no way it will be destroyed until you specifically go ahead and format your hard disk or delete, or the hard disk gets corrupted. Okay, now these guys were seeing the uh, see, everything has a plan of execution, right? So these guys were seeing how the big data how Hadoop is processing the things and all, and they thought that is it a necessity that every time you need to do a disk input and output? So when I say disk input and output, you store the data in the hard disk and you fetch the data in the hard disk. So you want to say you have 100 GB of file, okay, or say you have a sales data of last 10 years, which is like billions and billions of records, okay, you store it in your hard disk. Now your manager says that, boss, I want the sales data for January 2021, not 2022, 2021. So usually what would be the process? You will pull out all the data from the hard disk, okay? You will do some filtering on the logic, then you store that filtered results in the hard disk, then again fetch that result from the hard disk, apply some filter criteria where clause greater than equal to, again write it back to the hard disk, and then show it to the user, right? This would be the process which you would follow. So what is happening? Multiple hops on your hard disk are being happening over here, right? Wherein you are reading from your hard disk, processing it in your CPU, sending it back to the hard disk, taking back the intermediate result from hard disk, processing in your CPU, sending it back again to your hard disk, processing getting it back from the hard disk, processing it in your CPU, writing it back to the hard disk, and then showing it to the users. Okay, so this is what you are doing. So to achieve that sales result of January 2021, imagine that you are writing to the hard disk 5 times because of 5 intermediate steps. Okay, you are joining the table, you are filtering the values, you're doing a where clause, you are having a value having clause, and things like that. So every time you are writing it to your hard disk. Okay, when you are writing to your hard disk, what happens? Writing to the hard disk takes little fractions of a second. So see, when we are talking about okay, I'll come back to later. So you are losing your time in writing the data back to the hard disk, but what is the end result which the user wants? The user just wants the sales data for January 2021, right? Amongst the sales data which is present from 1980s in my database. Okay, I have data from 1980s. I want the sales data for January 2021. So 4 steps are required to do that. In a Hadoop world, every step you will write the intermediate data set back to the hard disk, wherein you write. So everybody should be aware. I understand that at least this basic we all know that in the computer world, we maximum amount is taken when we write to the hard disk or read from the hard disk. That is the maximum amount of time which happens for processing anything. Otherwise, processing happens quickly, but the majority time taker is when we write to the hard disk or read from the hard disk. This is the pointer where these genius guys felt it could be a challenge. What if, see, the end result is that the person just wants the sales data for January 2021. Do I actually need to write the intermediate stages in the hard disk? It might not be written, right? Because at the end, what has my manager asked me? My manager has asked me to give me the sales data for January 2021, right? So just imagine this case. So you have to come from source A to source B. Okay. Now there will be one person who would go to source A to C, then D, then E, and then he will come to source B. But there is one person who thinks that, boss, irrespective of the intermediate operations, what happens, my boss just wants me to go from point A to B. Let me take the shortest path. Why should I go from, and the defined path is, say, or let me take it that way. So you want to go from, let me not take the concept of Bangalore. So yeah, so just say that you have to go from you have to go to from Kashmir to Kanyakumari. So that's an extreme end of Indian subcontinents. Okay, you need to go from extreme north to south. So one way is you take a direct trajectory, you go from north to south directly, right? The other way is you go from north to east, east to west, west to say northeast, then come back, and then you come to land that way. So you take a zigzag route. Okay, because that zigzag route is the ideal way. It's an ideal route which everybody has defined. But I want to be unconventional. I want to directly take a straight trajectory, grow from north to south, right? So this is what, because anyways, somebody has asked me to reach Kanyakumari from Kashmir, which are from north end to south end, or say from north pole to south pole. Which continents I take in between, whether I go from I travel to Australia, I travel to Asia, I travel to South America, I travel to Africa, and then come to the southern continent. No, I can so I take a ship and I go directly in the in the ocean and reef. So this nobody, because the end result is what is more important, right? So that is what these guys pinpointed, that if let us do one thing, let's do something to let's do something to reduce this input and output of intermediate stages on the hard disk. Let everything be in the RAM. But now everybody knows that what is the problem with RAM, which we call the random access memory. The moment you shut down your laptop or the power off happens or something, what happens? You lose the data, right? This is a only this is the challenge with this approach, that with the hard disk approach, the best thing is, if you save intermediate steps, the moment power goes off, when you want to start, you can still start from the point where you have left on the hard disk. But in this current scenario, the moment power off, you lose everything, right? So we have a solution for that as well, but this was the only challenge. Otherwise, this was a perfect approach, correct? You have data from 1980s to 2022, but I want just the sales data of January 2021. I will not write the intermediate stages in the hard disk. Rather, I will let it be in my memory or the RAM itself, which is the random access memory, or the memory which gets lost once the power is off. Correct? So I take a best case scenario, that when I have a good UPS, and I won't be disconnected from the internet and all, let me start this processing. So with this approach, these guys were able to achieve tremendous performance improvement. Okay, and that was the concept of Spark. Okay, everything was same as Hadoop, just that rather than the disk IO time, they reduce. So Spark has two capabilities. Hadoop has Hadoop distributed file system, which is distribute the files, divide and conquer and rule it. Spark as well, divide and conquer, rule it, a distributed file system. But the only thing is, be little more lazy, be little more smarter. Do not write anything on the hard disk until somebody asks me to write it. I will keep everything within memory itself. Okay, and only the last result I will show to the client or to my manager and then save it. Okay, because at the end I'm just concerned about the end result. Out of the data from 1980s to 2022, just the sales data for January 2021, I show that data to my manager and save only that data. I will remove all the intermediate steps, right? And that was a good breakthrough which the scientists achieved, and the processing became even faster. So say flower counting, which used to take 8 hours for 50,000, reduced to 1 hour with Hadoop, and with Spark, it reduced to say 10 minutes or so. So tremendous increase of speed or processing we achieved in Spark. Okay. So same thing. See, it's a PPT I would not like to read. Spark is a general purpose distributed data processing engine suitable for a wide range of circumstances. So these are the building blocks of Spark. Now, when we say it is a big data thing, it has to process streaming data as well. What is a streaming data? Data that comes in real time. I talked about the velocity of the data, right? That it can come at different speeds, it can come at different velocity. So a heartbeat tracker which you wear on your wrist, that has to send the heartbeat every second, right? But the sales data, or say sales data of a store, needs to be generated only end of the day, right? After 12 hours of a shift or things like that, right? So or say the sleeping pattern. Let's not go to different data source example. You everybody, most of the people wear these smartwatches where which monitors your heartbeat, and say it also monitors your sleep patterns. Okay, so the heartbeat is calculated every minute it shows, right? It will say last minute your heartbeat was 72, this last minute your heartbeat, or the minute before that it was 68, the minute before that it was 65, the minute before that it was 105. But when you are sleeping, what happens? It also captures your sleep pattern. So you see, the sleep pattern is captured over a period of 6 hours, 7 hours, or 8 hours you sleep, right? That is something which is distributed over 8 hours. So you see, the same data, the data which your smartwatch is receiving from your body, for your heartbeat it has to calculate, or it has to capture every say it captures every second, right? But the sleep pattern is captured over a period of hours, 6 hours, 7 hours, or 8 hours, you see. So the per second data is a streaming data, but the spread out data over a period of 6 to 7 to 8 hours is the batch data, right? So this engine, Spark engine, should have the capability for Spark streaming objects as well, right? It should have the why Spark SQL it should support, because at the end everything boils down to an SQL statement. I want the sales data for January 2021. Select star from table name where sales data, where age, where say uh, time or date is greater than 01 01 2021 and less than 31 1 2022, right? So to when you want a processing engine, Spark SQL is something which provides you the capability to query it. Okay, what is Spark MLeap? Spark MLeap is, now we are talking about the big data world wherein only reporting is not a desired output. People also want to do machine learning capabilities on the data, right? That is where Spark machine learning libraries are also very important, which will help you to do your machine learning activities on the Spark, right? So these are the capabilities which together make Spark. Okay, so okay, having said these things, I will quickly like to show how you can do some processing on Spark. But yeah, prior to that, a normal big data architecture. Okay, so we have talked a lot about big data and all. How do you prepare or how do you prepare a use case for your big data? So every big data problem can be broken down into this simple block diagram, very simple. Don't go to this data factory and data bricks and all. Don't get confused. This, see, once you all keep on easy things, once you keep on learning, you will once you start learning, you will come to know about it. So don't be confused by these terminologies over here. Just consider that these are different data sources. Okay, so it could be on premise data source, it could be structured, it could be unstructured, anything. Okay, now everything has to be pulled together, stitched together, and put to a storage layer. Okay, so you collate the data from different sources and put it in a storage layer. Once you have it in storage layer 1, you do some cleaning, processing and all, put it in storage layer 2. Once you want to do more, so just say that you are out in a gold mine. Okay, now do you think gold will come in its purified form the very first time you dig it from earth? No, right? You have to take it to process it. Same is the process for oil as well, and that is why people will say that big data is the new oil and all. So these drilling machines will go in the, it will go in the sea. What will happen? But it will start drilling the oil. So oil would be very crude, it will be black. Then it will do distillation, and then your finer petroleum jelly and all these things will be byproducts which will come out. The end result is a petrol or a diesel which you use in your car, right? But most of the time you do processing or cleaning of the oil. The same process is happening in the data as well. So you see, you get all the crude oil from different places. This is a drilling engine. Okay, in this drilling engine you keep on drilling and get the oil from different sources and store it in filtration plant 1, filter it, put it in filtration plant 2, filter it, put it in filtration plant 3, and you get the petroleum out of it, which you can put in your car. Okay, so a normal big data architecture, different data sources, some machine to pull the data together, store it somewhere, and start processing it. And this is one of the components which, so Databricks is one of the components which can be leveraged for doing processing on Spark. Okay, so Spark is nothing, it's a concept, it's a transformation layer, right? So you need to be able to run Spark somewhere. That is where Databricks is one of the components, Synapse Analytics is one of the components where open source, it's an open source tool, so you can start utilizing Spark clusters. So these are called Spark clusters, wherein you can start utilizing your Spark clusters to process your big data. Okay, so roles and responsibilities, we'll talk about who is a big data developer, will design and develop ways for data abstraction, cleaning, analysis using Hadoop, Spark, and big data services, right? So what number of you, yeah, and it's a switching between screens, but yeah, let it open so that I just wanted to show you the environment. Okay, yeah, you see what are the things you would need for being successful in the big data uh, ecosystem. So you see, you need to have good knowledge on Python as a programming language. You need good problem solving skills and all. You need to have experience in Spark, Spark ML, Spark streaming. Okay. Now, yeah, let's go to it's a lucrative business in India. People are earning good money. So it's a good time for you guys to start on your big data journey. Okay, so yeah, you could you could go for a guided course from Intellipaat. You can follow the blogs of Intellipaat. You could follow YouTube channels wherein you would be able to get your journey started. Okay, so you see, yeah, so let's take an example of, don't concentrate on anywhere. See, what do you see over here? Do we have a driver or a master? Do we have a worker? Correct. So there is a driver who drives the work, or a project manager who does the things, right? And there is a number of workers. So how many number of workers I am assigning here? Minimum two. It means that if my flowers are lesser in number, somebody gave me a basket of just 100 flowers, I will distribute it to two people. Somebody gave me a basket of 1,000 flowers, I will distribute it amongst eight people. Depending on my workload, you see, minimum to maximum it will scale on, and that is what my monitor or the driver will do. And you see, very simple. What does it says? 40 GB 4 cores machine, right? So it is nothing, but it is your laptop itself, right? One laptop might have how many? So imagine the kind of capability you are providing in this single cluster. How much, what would be the capacity of my laptop? Say a 10 GB machine, or say 8 GB machine. What is the processing power you are providing? You are providing here, let's see, minimum, what would be maximum? 8. 8 plus 1, 9. 9 into 14 GB is minimum what you are providing them, right? 9 into 14. So see, the RAM capacity is almost 126 GB RAM, right? It is what, I will not say it's not possible in 126 GB, but imagine going on to huge systems. Okay, so let me take you through this one. This should be minimum. Yeah, see, this is the capability for this cluster. How much I'm providing over here? You see, so max worker 8 into, so 9 into 32, 9 into 32. So see, the RAM capacity of this machine is 288 GB RAM. Imagine how costly it would be to purchase. Or have you ever heard of a laptop with 288 GB configuration? Probably not, right? But see, one single cluster is providing me such a huge capability, right? So this is the app, and you write your code over here. So basically that would be you. As I said, Python is very important. So what you can do over here is, you can go to so this is just a process. So say that I want to write something. Okay, so something can be written, but here what happens is you create a notebook environment. Okay, create, see, what are the language? Default is Python. You can use Scala, SQL, R over here as well, right? You create a notebook, and So you will say once you create a notebook, or let me open this. So you see that, do you see something over here that you can select a drop down? So so see, it is providing me now currently when it is running, it is providing me 64 GB. So some workload is already running on this. So 64 GB is what I'm providing. But what was the maximum capacity of it? Some 288 GB. But my data size is small, so it is just using 64 GB, but it can go up to 288 GB is what we showed, right? So you see, you need to provide a platform where this code will run. So that is the reason you have a drop down. So once I start running it, and you see the commands, see the fraction, how quickly they are running. 0.52 seconds, zero point 0.1. So it will just be in seconds and seconds. Okay. So see 0.02 seconds. So imagine how quick it is. Very quickly it will run. So that's an advantage of Spark. Okay. So this is one of the environment. It was nice interacting with all of you. Yeah. Have a good day and best of luck to everybody.